Am I live? Good. Excellent. So yeah, thanks first of all for inviting me. And yeah, so let's get right started here into it. And a little bit introduction first, introducing myself and what I'm going to talk about. And I put this talk together here just for you as a little bit of special one-off. Didn't really know what to expect here, you know, with this background. I absolutely don't mind being interrupted for questions. So please, if you have a question, if you want to go in a different direction, let me know. And definitely open to exploring different topics or so, whatever comes up, kind of. Yeah, we'll get it covered. But anyway, so a little bit about myself. I'm working for SANS. SANS, we're familiar with SANS. We do teach cybersecurity. We do have a university, a graduate school, undergraduate program that we're running, but also professional training that we are running. And for SANS, I'm the Dean of Research, which means, well, supervising students writing research papers, but also running what's called the Internet Storm Center. And I'll build my talk a little bit around Internet Storm Center. Anybody here familiar with Internet Storm Center or what it's about? Okay, a couple of you. Good, good. Yeah. I'll show you a little bit more about that later. As far as teaching goes, I'm teaching web application security. That's our Sec 522 class, as we call it, and intrusion detection, packets, basically. That's Sec 503. In info security for 20 years now, and I'm living in Springfield, so a little bit north of downtown here in Jacksonville. And originally, I grew up in Germany. And so how did I get from Germany to actually doing InfoSec in Jacksonville? Well, earlier you were asking about early Linux distros. It's actually a little bit related, so I didn't start out with that. But I would say it's a little bit like a superhero origin story. It involves radiation in the lab, where it sort of all got started. When I first came to the US, this was like, sorry, let me just get this before I fall over it. When I first got to the US, I actually came as a physics student. It was one of these one-year exchange programs, and I guess I'm still somehow on it. But I worked in a lab where we did X-ray optics. And X-ray optics, well, you try to align X-rays with little optics. You neither see the X-rays or the optics, and you try to align them somehow. But the one thing you want to do is you don't want to get too close. So I started writing software for remote control of these experiments. This is like early 90s. I got a cable modem at home. First kid on the block, kind of, with a cable modem. Actually, not the first kid on the block, and I knew I wasn't the first. Because back then, when you turned on your network neighborhood in Windows, you literally saw your neighborhood. So it was all like one big hub, I guess, or so how they switched it back then. But it was super cool, and I had now this reasonably fast, I don't know how fast it was, probably a couple megabits, but always on connection. It was a big deal. So the next thing I wanted to do is, well, connect to my lab from home. Now, back then, all my lab computers had public IP addresses. That's how we rolled back then. It was sort of 90s. Yeah? And, but the one problem I had at home is at home I only had one IP address. I had my desktop, and I wanted to get my laptop that I sort of kept carrying forth and back from school. I had all my software on it. So what do? D-Link, Linksys, those companies didn't exist yet. Yeah? IP chains, they called the firewall rules back then. You set them up with a lot of Googling. Google didn't exist yet. It was Usenet back then. So with a lot of Usenet news groups and such, I figured out how to do it. And I got networking, which was really new back then. And I was able to connect from my lab from home. I was so cool. Okay. So I had like a little Slackware was my distro back then that I had set up, like a little 386, something like this, that I set up as a router. And yeah, it worked. And first rule of networking. If it works, stop touching it. So couple months into this, I got the call from my ISP. Johannes, why are you sending so much spam? I'm not sending any spam. Well, back then, Linux wasn't just open source. It was an open mail relay. And okay, that's how we learn about security after the incident. So that's how you figure out that, yep, I probably want to turn off that mail server. I don't really need it. Oh, and those IP table or IP chain rules, there's actually a firewall behind that. I can block ports and do all kinds of cool stuff. Okay, so I got it all set up and got the ISP off my back, and then I made a second mistake. A mistake most people don't make. I looked at my logs. And what did I see? All these people are attacking me from all over the world. Like these spammers back then and such. So being in physics, I figured, hey, let's dive a little bit further into it, and let's figure out what we're going with. Let's collect some data. And around 99, I also switched jobs. That physics stuff was a little bit too slow, so I became a web developer, and so I've got more into sort of the Unix side. Actually, at work, we used mostly Solaris back then. We were just sort of switching a little bit to Linux, but just when Linux became sort of the serious, real operating system for a lot of the server work, kind of. We replaced like Oracle with MySQL and stuff like that. But Red Hat actually was the distribution we then switched to, I believe. But anyway, so doing all the web development stuff, I figured, hey, and I kept sort of working with a couple of friends where we sort of looked at our logs and tried to make sense of them, like these firewall logs, what sort of the attacks we were seeing. I said, hey, would it be cool if we just had everybody send us their logs? So I set up a little system called theshield.org, where it was like in 2001 we did that, where I said, hey, send me your logs. And people actually did. I don't know why, but they did. And it was really cool, because this was like around 2001. For those of you who are old enough to have been around back then, Code Red, Nimda. It was the time of these big ones, Blasterworm a little bit later. And we had great data. So basically, I set up a website, theshield.org, and people could send in their logs, and we plotted graphs and stuff like this. It got /dotted. It was a big deal back then. Actually, I was lucky. The server I built back then, I paid $400 for it, and had friends at an ISP who put it like on a shelf and connected it, sort of. And it was /dotted. It was actually a denial of service against the ISP, but luckily their switch was overloaded, so they couldn't connect to it to disconnect my system. So I stayed up that way. But anyway, and yeah, the power supply caught fire and started smoking. It still started running for a couple months after that, like just some insulation kind of burned off. But anyway, enough about that. So that's how I got then more into security, and then later, after being a web developer for a while, I switched full-time security and working for SANS now these days. But anyway, so why Linux? Well, Linux is great for you as users, and hopefully not for you as attackers. Linux is powerful, it's easy, it has this neat scripting platform. Like I always say, there are two kinds of Linux people. The ones that know how to script, and the ones that will be replaced by a script. Or these days AI or whatever kind of, it's going to replace you. But yeah, and Linux is everywhere these days. And like IoT, or as I call it, the mosquitoes of the internet. Really deadly in big numbers, kind of, but otherwise just annoying. So anyway, and yeah, Linux has vulnerabilities. Telnet-D, that's sort of lately all of a sudden. There was a couple weeks ago where you do telnet -F root, it just lets you in as root. Now, I don't know why it took 20 years for people to figure that out, but yeah. Or this came just out this week, where there's a simple buffer overflow in like the telnet negotiation, also gets you instant root access. So yeah, pretty neat vulnerabilities. You try to make Linux more secure, use AppArmor. Last week, someone came out with Crack Armor. There's actually a vulnerability in App Armor that turns it into a privilege escalation vulnerability where it can become root if you have App Armor enabled. So yeah, can't win kind of, but that makes it fun. Yeah, and here another sort of privilege escalation vulnerability, snapd. I'm not a fan of Snap, kind of not sure if anybody uses it big time, but yeah, it also has sort of one of those where you use deleted directory quickly enough, one of these vulnerabilities, you can basically also escalate privileges. But anyway, so lots of vulnerabilities in Linux. Now, still, as a Linux user, you probably still feel reasonably secure, and rightfully so. It's not that Linux is horribly broken, because the big problem is which vulnerabilities matter. Like, who has Telnet running here? Good not to see too many hands going up. So that's one of those big things. So that, but anyway, so that's sort of where we come in a little bit in the Storm Center, where we're looking at what vulnerabilities actually matter right now. And it was from the ground up designed as a very open information sharing system. We take all data in that you send us and display it on our website. So trying to get a little bit of that open source, open data kind of momentum going here. Where do we get the data from? Honeypots. Now, the very first sensor that I deployed was actually a one-liner bash script. It just grabbed the IP tables logs out of your syslog and piped it to emailed it to me. It was our very first sensor. Worked great, actually. We still have people using it 25 years later. So, but what we do these days is, because just firewall logs, that was cool in the beginning, like with these early worms. These days, and we'll talk about this a little later, pretty much all of your attacks are web application attacks or sort of SH brute force and such. So the port doesn't really matter that much anymore. So we need more data. We need richer data, and that's what we get from these honeypots. Now, we standardized it a little bit on Raspberry Pis, but it runs on anything Ubuntu or such. So it's fairly flexible what you're using to run it. I just displayed as a Raspberry Pi here. And what we created, I call it our agile system. So the honeypot just sits out there, waits for incoming connections. And then it responds. So it gets a web request, HTTP request. Now it responds. What we can do with these honeypots is we can tailor the response based on the request. You're sending me a WordPress exploit. Hey, I'm WordPress today. You want to exploit toasters? I'm a toaster for you. So with that, we can basically give you whatever you try to exploit and then hopefully see some of the later steps of the exploit. And I was compared a little bit to like sort of astronomy, which is sort of what I used to do way back in the day. There's sort of two ways to do astronomy. You have sort of these full sky cameras that look at everything. And they're great kind of, for these sort of some flare or something like this coming up. You don't want to have to point your telescope in the right direction. And you have telescopes that can really zoom in on a particular star or some interesting event. That's the other thing we can do here. We can basically either configure them to just be very generic, or we can configure these honeypots, and they sort of check in with us once an hour, basically get the latest configuration. Or we can say, hey, we just saw in a couple of our honeypots this real neat attack that's kind of new and different. We're not sure exactly what it tries to do. Let's configure all of our honeypots to like cover the couple possible like vulnerable systems that they may be looking for. So that's what we can do, and you can participate in this. We love data like from home users and such. That's always great. So it's not that you need a big internet connection or such. And there's even like a little SIEM sort of an add-on that then tells you basically what attacks you have seen. You can sort of dive through the data and such. That also makes this a little bit more exciting. Like I always say, greatest thing you can do is once a week, packet night at home with the kids. Just take the honeypot, put up like TCP/DOM, Wireshark, look at what the different attacks are. Tons of fun, tons of fun. But anyway, so what attacks do we get? Firewall logs, that's sort of one of our big things. So of course, we still collect them. We use Telnet and SSH. Anybody familiar with Cowrie? Cowrie is sort of an emulator for SSH and Telnet. So that way we don't expose the actual system. It's a Python script. When you connect to it, it looks like it's Telnet or SSH. And then web server logs, what I just described. We also collect things like domain names, for example. So what are all the new domains registered in a particular day? And that is obviously sometimes some neat intelligence, kind of what we get. But anyway, yeah, let me just show you what it looks like. So isc.sans.edu, that's the URL here. We always have diaries. Why do we call them diaries, not blogs? We started them back in '99. Term blog only came up sort of later. And I kind of like diary, kind of. It's about what we saw these days. That's really a little bit what it is. So here, for example, adminer, anybody familiar with that? We see some new attacks against that. It's a little MySQL web-based admin script. But then when we sort of look at the firewall data here, like I said, these are the top ports currently being attacked based on the firewall logs. Like, this is kind of boring. Yeah? Port 80, web, 22, SSH. That's pretty much it. And they have sort of variations of that. The 68, anybody knows what 68 is? DHCP, yeah. And I think that's a false positive here. That's just the honeypot picking up some DHCP traffic on the local network. Actually, I have to see why we even get that. 1688, that's a little bit of a weird one, actually. And you know, with our data, all the data is open. So you just click on it, and it tells you more about it if the website responds. Yeah, here it comes up. But yeah, BitTorrent. Yeah. So that's also some, basically, I would call it false positive. Now, people ask, why don't you remove all the false positives? Yeah. Well, if you tell me what all the false positives are, I rather don't remove anything and let you decide, you know, what you call a false positive or not. And sometimes we get some interesting stuff then on ports like that. Top IPs, and you can click on that and see what that IP is all about. One way to use the data, for example, is you see an attack against your network that looks like interesting, different. Plug that IP address into our data and see how many other people are being attacked by that IP. If it's one of our top 10 IPs, it's probably not an interesting IP for you. That's some stupid infected system. If you're vulnerable to whatever they're looking for, it's too late, go home. Or it's like one of those companies that just scan the internet for like vulnerabilities like Shodan or stuff like that. Anyway, this is actually sort of interesting. It's Proton VPN here, this particular one. So someone using BitTorrent via Proton, I guess. You know, that's sort of probably what's happening here for this particular one. But anyway, so we have the ports. Then from our web honeypots, we get our web logs. Let me also already preload the next one here. Yeah. And what I always look at here is the first seen URLs. These are URLs that we haven't seen before. It's kind of the new stuff. I say kind of, and you'll soon see it when it comes up. A little bit slow here. I always blame the internet, but it's probably my server.
You can blame the internet.
Yeah. GS5662D34. Doesn't really sound like an easy password. It's a default password for one of those video recording security things, kind of. Just happens to be default password. And yes, attackers are looking for it. I was actually just looking back, and there was, like with Iran, a lot of talk about them attacking cameras again. I was trying to look in our data. Do we see these attacks? No, because there's way too much. A couple Iranians don't really matter. When we first looked at this was about 10-ish years ago. We saw some of the early attacks like that, so very basic brute forcing passwords. We're going after Hikvision cameras. Yes.
I was just wondering, so are you saying that they are attacking SSH using these camera passwords so that the cameras have SSH exposed, or they're like mis-spraying them?
So the question here was, do the cameras have SSH exposed? Yes. Or Telnet.
Oh, wow.
Or Telnet, yeah. Yeah, and these Hikvisions, it was actually Telnet with the Hikvision ones. Password was 12345. We had a lot of them at the Panama Canal that they had hacked, and they used them for crypto mining. It was one of the saddest crypto miners ever, because they don't have a CPU like these cameras. They're very minimal, and actually when we wrote about it, the people behind that botnet gave us access to their admin panel. And they had something like 10,000 or so cameras in their network. They made about $1.20 in Litecoin. That's what they were mining, but and that's why they sort of basically just had fun with it at some point. Yeah, and with that camera, to change the password, they give you, it comes like with a monitor and a mouse. And then there's an on-screen keyboard that's numeric. Now there's a very small button if you get an alphanumeric password, but nobody's ever going to change that password. Yeah? But anyway, so SSH is one of the things, so that's how Linux gets attacked. Telnet if you enable it, but really it's equivalent. Encryption doesn't matter here because they're just using weak passwords. What are they doing? Crypto miners is still a big deal. So it's still what they're running. They're using it as attack infrastructure. Anybody familiar with MikroTik? MikroTik is sort of a fairly popular switch router. A bunch of them were hacked and used. They basically, attackers like sort of these residential small business systems because then they can route their traffic through those. And that way basically disappears. It's the attack infrastructure. MikroTik was attacked big time a few years back by an ATP actor that sometimes referred to as the Equation Group. I'll let you look up who that is. But they basically built sort of their attack infrastructure with these residential MikroTik routers. And web shells, doesn't really matter what they get into. Your Fortinet stuff or whatever, a web shell is the first thing they install. Divanti crap, kind of, that's also all web shells, kind of what you see there. And then web shells really a form of backdoors, but I'll talk in a second a little bit more about the SH-specific backdoors. So this is kind of what a typical attacker does after they connect to you via SSH. Yes. Oh, yeah. This one?
Yeah, thank you.
Question about it?
I just wanted to, I'm taking notes.
Okay, yeah. The slides, I'll make them available.
Okay.
Yeah.
Yeah, you're right. Sorry. Thank
Okay.
you.
Yeah. Make their .ssh. Anybody knows what's in .ssh? Yeah, your SSH configuration keys. And then they add their own authorized key. So later you come back and you say, oh, someone hacked my system. I probably should change my password. Doesn't matter anymore at that point. And then just for good measure, change adder plus AI. What does that? Immutable, yeah. So now even the owner of the file can't change it anymore unless, of course, they figure out to do change adder minus I. But yeah, so anyway, that's actually one of our undergraduate students. They sort of run some of the honeypots and analyze some of the attacks. I copied that from a report that he wrote. But it's very, very typical. You see that 100 times a day, kind of. Yeah, so how do we defend? So how do we defend against some of these attacks? So one of the big, big targets is this authorized keys file. You definitely must secure it. That plus I trick, make it immutable, is not a bad idea. The owner of the key doesn't have to have write access at all. You can just make them writable by root only. And then actually one thing I like to do is take them out of the user's home directory. There's a simple configuration directive here, this authorized keys file. You just tell it, hey, they're all in this authorized keys directory, and then %u, that's just the username. And now you have Ansible or whatever, push it out. The user never really touches that file directly. And with Ansible, of course, you can also make it nicely, you can monitor it basically, or whatever tool you use to sort of orchestrate your stuff. Yeah, that's sort of one easy way to basically defend against these attacks. Yeah, definitely different keys, different users. It's like a password in that sense. It's just a password you don't know. So that's really what that key is. You may want to consider different keys for different systems and purposes. That depends on how you manage them. I'll show you some tools in a second that make that a little bit easier to do. Passphrases for keys. Yes, it's a little bit of pain. You have to type something. But SH agent to forward that makes it really easy. And then you can keep them all on your laptop or whatever you use to connect to the systems and reduce the exposure there. Issuing these keys, there's some neat ways. Now, most of us use basically one private or a private key, public key thing. You can actually use certificates instead of these keys. And then the server you connect to only knows as long as the user has a certificate signed by the certificate authority, I can take out that user and trust it. And now you can make those certificates short-lived. You get a new certificate each time you log in. Automation is key here. Small Step is one sort of semi-open source tool to do that. That basically you can get the key, you get the certificate, use it. It's only valid for a very short time, and then it's basically removed. Yeah? But yeah, so that's the tricky part. Is if you need to automate stuff, so scripts, and then just limit what the key can do, what it has access to. That's probably the biggest thing here. And here are a couple of things that you can do, like from where you can.
For the users,
yes.
For the keys, you could even limit it to like not even the device, but the user itself. Like I know YubiKeys, you can use those right there.
Yeah, I have my YubiKey here, and you have the SH key on there, or in your password manager you can store them and such. So there's lots of good ways to keep them safe. Yeah, with that you limit, you can only connect from certain IP addresses. So you can only connect from like your workstation, your internal network, depending on how fine-grained you want to make that. You can set up an expiry time. By default, like your default SH key lasts forever. There's not like a certificate, like an expiration or so in it, but you can define one the authorized key file if you want to. And these commands, so you can say, hey, as soon as you connect, execute a certain command. Sometimes people use that to put you like into a more restrictive shell or something like that. You have to be a little bit careful. There have been many, many tricks and workarounds to not execute that command. And then also these restrictive shells aren't always as restrictive as you necessarily think they are. Alerting. I do that on high value systems. Like I have sort of a little bastion host out there whenever, so I can connect to it and then connect back to my home network. This is sort of a little bit emergency access. In the, do I have it here? It's in, yeah, here, etc profile D. You can put a login.sh script. It's executed each time any user logs in. Successfully, yeah. Yeah, so you don't get false alerts if someone just brute forces. And that would be highly annoying. And here, for example, I just used Twilio to send me a little SMS. You can do the Telegram or whatever kind of, whatever you feel is good enough kind of for that purpose for you to alert you. And that's like for stuff basically where you hardly ever log in, which are sometimes the most dangerous accounts, because an attacker could take that over and you wouldn't notice for a month or so because you never really used that account. Yeah, a couple other things. Anybody hopefully runs SH on a different port. I think that's just good practice. It keeps the noise down. I would say security by obscurity isn't the end of it, but it's a good first step, kind of. It helps. Port knocking. Anybody heard of port knocking before? Okay, many of you have. Yeah. So you first connect to one port, then that opens up the actual port. There's also something called anti-port knocking. If someone connects to port 22, you automatically lock them out from all other ports. So that way they don't see the other stuff, kind of. With IP tables, there's like that recent module you can use. So it's really just a couple of lines of IP tables code. You don't have to install any real software or so to implement that. With the recent module, you can basically tell it, hey, whenever someone connects on port 1245, add them to that list. And then the second rule checks if that person is on that list, then give them access or don't give them access. So that's how you can sort of configure that.
So basically it's like a password kind of thing.
Yeah, like it's almost like a little password, like a combination. Yeah. And again, it's not meant to be 100% secure, but 99.99999% of SH attempts you'll see are those stupid Mirai bots. And you just want to basically get the noise down.
No, you're right, because I set up an Azure machine,
Yep.
and most of the attacks were coming from most common ports, right?
Yep.
And they all try to install something stupid and they get into it. It's
Yep.
crazy.
Yeah, so you're saying like an Azure, like on a cloud-based machine, which makes it obviously a little bit more difficult kind of to restrict access to it and such.
But that's a good idea, because they usually go to 22 port and it's,
Yep.
if they attack it, then block all the other certain ports and just put it on block list.
Yep.
Yeah.
Yeah, so just basically cut the noise down really. You have to be at least this tall to attack my system. If you don't know how to get past that, then I don't want you to attack my system. Yes, sir.
There's also a couple of utilities that essentially automate that for
Yep.
you, like SSH guard.
Yep, SH guard. There's another one. Fail to ban, yeah, fail to ban. And fail to ban is nice because it goes across different protocols and such, can look at application logs and yeah.
If you want to be really, like, use endless SSH.
Endless SH?
Yes. I believe if you try to, what you would do is you would stage, like you would put it on port 22, and then you put your real SSH port on another one, and if someone tries to connect to that SSH port, typically using like an automated script or something, it just serves them an infinite banner. So it
Oh, okay.
blocks them
Yep.
it gets them stuck.
So endless SH, it serves an infinite banner. Interesting.
Just
Now,
provides infinite banner, yeah.
what you also can do is, you can send that to a honeypot and then send us the logs. But anyway, so much about SH. The other thing I want to talk a little bit about is web. Everything is a web app these days. And yeah, I created a slide, I think, yesterday, and it's still this. It's pretty predictable, kind of, yeah? What you'll see here. And one of the things they keep looking for is secrets. Your API keys. Hot commodity these days. AI API keys. And stuff like that. Yeah? Running up your bill. That's really what they want for the most part. Sometimes steal your data, but really, they already have your data. So, yeah, so if it's these APIs, and what you really need to do to get under control is what's often referred to as secrets management. And that tends to be hard. Anybody here a developer? Yeah, so it's your fault. Yeah, because yeah, how many API keys do you deal with these days, kind of in your average application? Yeah? And then you need them for development. Yeah? In the old days, I always said nobody writes code because everybody uses libraries. Yeah? These days, nobody writes code because everybody uses APIs to do the actual work.
That's why we have SAS and DAS SAS. And
Yeah, SAS and DAS, so that finds some of that. Yeah.
you can shift the security to the left.
Yeah, the shift left, yeah, so to get in the design right. Yeah. And if you design secrets management into the application as a requirement, then it actually is doable. Where it fails is, hey, I have this great idea. There's this new API, this new AI tool I really want to play with. Let me get an API key for it and set it up and get playing with it. But that was yesterday's tool. Today you are in a really interesting other tool kind of that you really want to get working with, and you forget about the one you did yesterday because these days what happened yesterday doesn't matter anymore. Yeah? And then you sort of end up with these dangling keys all over the place. So the minimum that you should do is what's after first is well-protected file. Good luck well protecting it. Yes, you can play with permissions, but your application needs to be able to read it. You can monitor it, but anybody ever played with SE Linux?
Yes, literally. I hate I'm a huge ALMA Linux user.
Yeah.
A lot of instructions I see sometimes online where people will be like, just disable SE Linux for this, and I'm just like, why?
Yeah.
If you're doing that, then you don't understand.
Because it's hard.
It is, but you know what? I will say this as somebody who like
troubleshooter.
Yeah.
as somebody who does image deployments and stuff, right? You'll get these SE Linux errors, and you have to dig in and figure out what it is. And usually disabling SE Linux fixes the problem. Like, okay, cool, what's wrong, right? But if the solution is to get rid of the tool that's supposed to protect you, what's the purpose of it?
And I exactly get that, yeah. And sometimes they're just noisy. Like if you do alerting or so on access, and how many alerts does it take before you stop looking? To me, it's 3 maximum. I don't have a lot of patience with alerts. Yeah, encryption, host-based encryption is again hard. Then you end up, where do you store the keys for the encryption? Yeah, you have some, hardware security device or something like that. But if you get to that, you may as well do it right in the first place, kind of. Anyway, my full disk encryption. Use something like Lux container or so to put your stuff. I've seen this. You put your database in an encrypted partition. Does the attacker really care if they're using secret injection?
It's for data at risk.
Well, yeah, it's my doctor here in Jacksonville. He's in Riverside, and I remember a couple of years ago, this tropical storm came through and flooded downtown. His office was flooded, and I got back after he had it fixed up. He told me that he has his server in his office. The hard drive was above the waterline. So he figured easy replacement, get the hard drive, buy a new server, plug it in. The BitLocker recovery key was in the bottom drawer in the same office, which and was no longer readable. So, anyway, so encryption at rest is actually on the network. It's easy. Turn on TLS, but at rest it's really hard to get this right.
Sometimes you have the regulations, you just have to.
Yeah, regulation. And that's what I usually see is or people buy those stupid appliances, kind of, that. There are some cases over cloud or stuff like this where.
Those devices,
Yeah.
you really want to watch out for those devices because if you lose your, if they're a RAID or
Yeah.
if it's encryption or something on there, if you lose the core device has your metadata or your key structure, and you just lost the entire
Yeah.
array, even if
Yeah.
you tried to find it.
The common is they may have one of those encrypted arrays and only one of the disks actually has the key material. And that happens. AWS now started doing that. AWS in SS3 encrypts everything, but the keys are by default managed by Amazon. And they give you the option to have like these customer supplied keys, but I have like the big warning. If you lose that key, don't call support, because the point is that they don't know where that key is. Yeah, here's one open solution sort of for secret management that I think is not bad. It's a little bit pain to configure, in my opinion, but in physical, anybody ever use that? It's sort of one of those freemium kind of things, like you get, in physical is the name of it.
They're mostly cloud native.
Yeah, but they also can do like certificate management and SH keys and stuff like that.
To be vault-like.
Yeah.
HashiCorp vault-like.
Yeah. Yeah, it's a little bit of a HashiCorp idea. Yeah. So that's an option that you have, but it's probably only worth the pain if you have a larger deployment.
This does a very good job with the KMS key that has
Yeah.
the keys.
Yeah.
It's pretty awesome.
Yeah, here the AWS. So AWS does a pretty good job. They can even like define lambdas to rotate stuff and such. So that's not bad. So I put them here under commercial, even though of course they don't charge you for it. You know, or actually they do. It's I think 40 cents a month per secret or something like that. Yeah. HashiCorps are the biggest one here, I think. 1Password is actually not bad for developers.
Use Terraform and OP command line.
Yeah.
Store password.
Yeah, 1Password, I think the command line tools, and I find that the best solution, I think, for developers. It's not free, but it's cheap enough where
Oh, it's really cheap.
if you're doing it professionally, it's probably worth it. But anyway, yeah, so these are the big two problems I see these days. One, SSH, you just have to get that secured. And like web apps, I focused on one point here. I could talk 6 days about web apps. That's why we have a web app class, but there's a lot more there. It is, on the other hand, always of the top 10 things, always the old stuff that usually gets you with these vulnerabilities, which is a little bit the sad part sometimes. And anyway, there's another topic I just want to cover because it keeps coming up. Anybody using one of these?
Yes.
Yeah.
Love those. Awesome.
Yeah. I think I have both here at home. IP KVMs.
A ton of new like KVMs. Like they now have one that's like a 5G IP KVM.
Yeah.
So you hook it up and you can connect to your device over 5G. So if your internet literally goes down, you can connect to it. And they're releasing another one now, which is like an all-in-one USB-C plug-in. So you just plug it in and it takes care of power, video, keyboard, mouse.
Yep.
You have IP.
Was it GLINet?
GLINet.
Yeah, GLINet. They're a little bit newer to this, but I think the cheapest one is here. This Cypete, I think they call them. You can get like the bare bones board here for something like 20, 30 bucks or such on Alibaba. If you want it with a case, it's like 40 bucks. Some people complain that there's a microphone on these. The reason there's a microphone on them is not because they want to spy on you. They had that board around for some other purpose and they had a microphone on it, which they actually also sell. And it was more expensive to rip the microphone off than just leave it on there, kind of.
So you can rip it off.
Yeah, you can rip it off if you want to. I'm not sure if it breaks something, but yeah.
I have heard some things online about, and I haven't really verified this, but about malicious like PyKVM distributors. You'll see them like, online, like where people will they'll market it as a PyKVM board, but the distributor might not be verified. Or whatever. I used to run PyKVM, and I've switched over to the GLINet.
Yeah.
But yeah, I've heard about like these IP KVMs are like super dangerous. Like you connect to the system.
Yep, and that's it. These are dangerous because.
It's the crowdfunded.
Yeah, that's the GLINet. I think I sort of I buried them a little bit because they're all kind of the same thing. I want to endorse a particular vendor here or hit on one. But anyway, there's sort of your out-of-band connection. Like particularly if you have the 5G, then it definitely goes past your firewall.
As a hacker, you just plug these into an air gap system and just walk away.
Yeah, There's actually like the OMG cable and such that actually has that capability. But you really want to be the hacker. So they're extremely useful for that out-of-band access. But they're also extremely because they give you that out-of-band access. So you have to control them. Number one, patch them. Paul Asadorian, he just came up with a list. These are actually not the worst, these vulnerabilities. If you look at the CVS scores, some of them are just missing brute force protection. At NGIT, GISO, whatever, how you pronounce that. I'm not familiar with them because there's absolutely no response if they'll ever patch it. The others have patches coming for it or already have them deployed. And like I said, for some of that, I wouldn't justify like an emergency update or something like that. So you're reasonable good with the others. But what do you want to do? Now, what people always say first is isolate. Well, so put it behind a firewall. But then I can't get to it to connect to my firewall and reboot it. So that's a little bit of a tricky proposition here. Strong authentication, I think that's table stakes. Have some second factor. And I have the PyKVM and the SciP, they both have the ability to set up like some simple one-time password, like Google Authenticator style, which I think is okay. Definitely TLS, because you do want to connect from various networks to them. And yeah, get a real certificate. Because if you get used to clicking OK on the bad certificate,
Cheap domain that you own and
yep, buy a cheap domain and do like your Let's Encrypt Acme. Do you know you can now get certificates for IP addresses with Let's Encrypt? Yeah. They're only valid for 7 days.
Yeah, you do Cloudflare.
Yeah, Cloudflare gets sort of the first step, but then you have to get from Cloudflare to your device.
Right.
And putting in Cloudflare as a proxy may not be a bad idea. I haven't tried it yet.
Use their zero trust network, and then you just
Yeah.
as an extra layer on top of that,
Yeah.
you can like say like, hey, you can like
Yeah.
you can narrow down the access on top of giving it
Yeah.
TLS certificate.
And so that and then logging. And you don't want to have a back door without any logs that tell you, hey, when was it used? How was it used? Is someone trying to get in? So you definitely need that. And the system you're connecting it to, you probably want a password. Like bias passwords now become more important. Like I would say for a standalone desktop, I wouldn't be that worried about a bias password. But now it's remotely accessible. And if you have someone flash a malicious bias or something like this, it's game over. You'll never know what happened. And you never know that it happened. Yeah. And that's why logging is really, really important. And again, these are not devices you use that often, at least in my use cases. I know sometimes people I've seen that sort of, anybody here still working in an office? It's still a thing. I haven't in like 25 years. But anyway, so yeah, I'm feral now. They can't put me back in office. So yeah. Anyway, yeah. Summary. Linux is security attackers. Your exposure, limit how your system can be used remotely or accessed remotely, nail that down, nail authentication down. And you're probably better than 99.9% of the systems out there. And you know the old story of hiking in the woods. Yeah? The bear comes. You don't have to outrun the bear. You have to outrun your hiking buddy. It's anyway, and yeah, keep it simple. Don't overcomplicate security. And that's like sometimes with the SE Linux stuff and such, where people get a little bit too fancy, and then it doesn't work, and then they turn it off, and yeah. So like, stick to basics, keep it simple, and that usually helps a lot more than trying to overcomplicate things. But anyway, any questions? That's LiFu on the left and LiWang on the right.
Have you heard about the no pitch virus by Russia?
Yep, that was the Russian against Ukraine. Yeah, this was a pretty neat one. It was a wiper too.
It's still going on actually in Europe. All the big
Yep. Many of this malware never really quite disappears. It just changes. And it takes years and years kind of for it to actually disappear and go away.
Yeah, because they use the internal glue from NSA.
Yeah.
To, they made a very clever malware virus actually. It's still spreading until you figure out the actual node and kill it.
Like the same with Mirai. Mirai never really went away. It just sort of mutated. They added more exploits to it and stuff like that. Once they had this really efficient scanning engine for SSH, that sort of did it. I used to give talks. I have at home one of those vulnerable DVRs, and I would just put logs from the DVR up on the screen and introduce myself. By the end of my introduction, I guaranteed had someone in the taking over that DVR. It usually only took like about 5 minutes. We measure on the Internet Storms, and one of the things we measure is the survival time, which is how long it takes between attacks on your system. When I first started, it was about 15 minutes. Now it's less than a minute. Like each minute you get a couple of random hits against your system. Yes, sir.
You mentioned something about the LiFu environment. You're going to try to look into that and maybe raise your bill.
Yeah.
What if I hide those things in virtual environment? Is it still possible to check those? Or
Hide them in what environment?
virtual environment?
What you hide in virtual environment doesn't really matter. Yeah, it doesn't really matter. Yeah.
Does or doesn't?
It does not. Like the Python virtual environment, yeah, it doesn't really matter. It's really, the Python virtual environment is not a security feature. It's just for developer convenience to have isolated libraries so you don't have like that stupid Python confusion.
What would you recommend if I have to use API keys or passwords?
Yeah.
Like the Raspberry Pi, running it on
Try to come up with some simple secret management. Yeah. And like I said, the least you want to do is that one file that you pay special attention to. But like I said, that's the absolute minimum. Yeah. So you don't have them littered all over the place. Yes, sir.
Is there a way to see on that Internet Storm site if there's attacks targeting specific devices?
Is there a way to see if the attacks attacking specific devices? Not off the bat, kind of. You can look for URLs that are being attacked. If you know that device usually attacked using that URL, you will see that. You can search for that.
Specific implementation of SSH for VxWorks or something like that?
You wouldn't see that. You wouldn't see sort of a specific attack and specific SSH implementation. And for the most part, the attackers don't actually care. Yes, ma'am.
I read a blog post about a guy who was doing some weird stuff with his network, and he noticed a weird API on his router, and he had to contact the company for the router to get it fixed. Is that normal, or is there something we can do since we're developers if we see a weird IP address doing weird stuff on your router?
So if you see a weird IP address doing weird stuff, or if you see weird behavior, I'm very surprised that the router manufacturer picked up the phone or replied.
It was a bomb over years.
I had an interesting case a little bit like this. It was not an attack in the end, but my wife bought one of those automatic cat feeders. Not sure why, but in my network monitoring, I saw that the cat feeder connected to Baidu.com every 15 minutes.
It was something like that, yeah.
Yeah, and so it drove me crazy, kind of. You know, what's the cat doing here? But anyway, so turned out it was of course a Chinese-made device, and they used a Python library to check if internet connectivity existed. And they used basically Baidu.com, just, hey, if I can connect to Baidu, I have internet connectivity. And because it was built in China, they can't connect to Google, they use Baidu kind of. So there was nothing malicious about that. But these kind of things you have all over the place.
That's why there's so many noise that it's hard to identify what is actually malicious and what is
Yeah.
just
Yeah.
Baidu.com, just as other devices do Google.com.
Yeah, and you have all these random things kind of. When teaching intrusion detection, my challenge I always give students is go home, take 10 minutes of your network traffic in your home network, and try to explain every packet. Yeah. You'll fail, but in the process, you'll learn about something new, kind of. Yeah? What's going on there in your network? Yeah. Okay, well, thanks everybody. I don't know.
Everyone for showing up.
Did I run over? I do have some stickers if anybody wants some Internet Storm Center stickers, so I'll put them out here.